Exercise 1.5 question 4. Represent root 9.3 on the number line. So for this, first of all, we are going to draw a line equal to 9.3 from this 10 to 19.3 I have taken here on this scale. So this is 9.3. Now let this length be AB. This AB is 9.3. After this, you have to produce this B point to say point C by 1 centimeter. So this I have taken BC. From B to C, this is 1 centimeter. This length is 1 centimeter. After B, from A to B it is 9.3, and from B to C I have extended this. I have produced AB to point C such that BC is 1 centimeter. Now find the midpoint of AC. For this, approximately stretch this compass more than half of AC. Draw an arc like this, another arc below this AC. Now from A, cut these two arcs. So join these 2 points. This is midpoint of AC. Let it be O. Now taking O as center and OA as radius, stretch this compass to point A. You have to now draw a semicircle. This is the semicircle which is drawn taking O as center. O is midpoint of AC and OA or OC as radius. Now at B, draw a right angle. Now you have to draw a right angle at point B from right angle or perpendicular to this AC. So this is 60 degree. This is 120 and bisect 60 and 120. So this is the perpendicular drawn at B from AC. Let this point and produce it till the point where it intersects the semicircle. Let this point be E. This point be E. The length of this BE is going to be root 9.3. Now if you want to express this root 9.3 on the number line, then you will have to draw the number line again. Take or mark points at equal distances on this number line. Let this point be 0. This is 1, 2, 3, 4, 5, and this is -1, -2. And now by your compass you measure this length. This length is, as I have told you, is root 9.3. This is root 9.3, and by measuring it here you can represent this length on the number line. Look, we know from this point O to this point A, this OA represents root 9.3. It's just coming more or slightly ahead of 3 because we know root 9 is 3. So obviously root 9.3 is slightly more than 3. So this is how we have to represent root 9.3 on the number line. Now the second question is rationalize. It is question 5 of exercise 1.5. Rationalize the denominators of the following. The first is 1 upon root 7. In this number, this denominator is an irrational number, root 7. We have to rationalize the denominator. That is, we have to make this denominator a rational number. For this, we are going to multiply both numerator and denominator by root 7, like this. So root 7 into 1 is root 7, and root 7 into root 7 is 7. So this root 7 upon 7 is equal to 1 upon root 7, only their form is different. In this form, the denominator has been rationalized. So this is how we rationalize the denominator when we have an irrational number like this, root 7, root 2, root 5 in the denominator. Now the second part of this question 5 is 1 upon root 7 minus root 6. So we have to rationalize this. In such questions, we are going to multiply numerator and denominator by root 7 plus root 6, which is just opposite of this sign, minus. So I am doing it here. 1 upon root 7 minus root 6 into root 7 plus root 6, root 7 plus root 6. Now this 1 into root 7 plus root 6 is root 7 plus root 6 upon this denominator is just like a minus b into a plus b. So we know the identity, algebraic identity, a minus b into a plus b is a square minus b square. So using this identity, it would be root 7 square minus root 6 square. So the next step, this product is root 7 plus root 6. This denominator will become root 7 square minus root 6 square. Now it is root 7 plus root 6 upon root 7 square is 7 and root 6 square is 6. So the answer is root 7 plus root 6 upon 1, and when we have 1 in the denominator, normally we do not write it. So it's root 7 plus root 6. So we have rationalized the denominator in second part. Now the third question is 1 upon root 5 plus root 2. So here we have root 5 plus root 2. So we are going to multiply numerator and denominator both by root 5 minus root 2. So it is root 5 minus root 2. Again 1 into this root 5 minus root 2 will be root 5 minus root 2. 1 into anything is that thing. 1 into root 5 minus root 2 is going to be root 5 minus root 2. Again we have got in the denominator that a plus b into a minus b. This root 5 plus root 2, root 5 is like a, root 2 is like b. Root 5 minus root 2. So it's going to be a square minus b square. So this will become root 5 square minus root 2 square. So it is equal to root 5 minus root 2 upon 5 minus 2. Root 5 square is 5, root 2 square is 2. So it is root 5 minus root 2 upon 3. This is the answer. The last part, fourth part, we have 1 upon root 7 minus 2. So we are going to multiply 1 upon root 7 minus 2 by root 7 plus 2, root 7 plus 2, both in numerator and denominator. We have to multiply same thing. We cannot multiply different things in numerator. So this root 7 plus 2 into 1 is root 7 plus 2 upon, again using the identity, it would be root 7 square minus 2 square. So root 7 plus 2 upon root 7 square is 7, but it's 2, it's not root 2, so 2 square is 4. So again the answer is root 7 plus 2 upon 3. So again we have rationalized the denominators. It is